Algebra 2, this is Chapter 7, Section 6. This will be the third video of the series. If I never happen to do video 2, just understand me that it wasn't hugely important. It's a geometry example. Again, this is example 3, hopefully the third video. So we want to find all of the zeros of this big, ugly function. So the first thing we want to do is we want to use our rational zero theorem and find out all the different possibilities, and we want to use Descartes to figure out which types we could possibly have. So I can start with Descartes. So let me grab, let's go red. So this is a positive to a negative. There's 1, to a positive is 2. So we could have 2 or 0 positive reals. So we go negative. This would stay positive. This one would go negative, this one would stay negative, this one would go negative, and this would stay positive when I fill in f of negative x. And so that's 1, 2 changes here, so that's 2 or 0 negative, which means that I have 4 total, which means I might have imaginaries 0, 4, or 2 imaginary answers. So I found all the different possibilities. The next thing we want to do are find which ones are possible, so that's using our rational zero theorem. So then we want to put P over Q, and P is 30, and Q is 1. So I want all the factors of 30 basically, so that's going to be plus or minus 30, and then plus or minus 15, and plus or minus 10, plus or minus 6, plus or minus 5, plus or minus 3, plus or minus 2, and plus or minus 1. Okay, so those are all the numbers that we have to test. So 1, 2, 3, 4, 5, 6, 7, 8. Possible test of 16 different numbers in order to figure out our actual roots here. So next thing to do is to test them. And so I'm going to put my test number, and this is going to be a little weird looking at this. Hopefully you can follow me. Know that we went 4, 3, 2, 1, 0, so we did go straight down. There's no placeholders needed when we do synthetic division. And we want to look at our numbers. So I'm going to start with 1 and test 1. So again, this is a little weird. I haven't showed you this before. This is synthetic division, but using a table. Know that this is a 1, this is a 1, this is a negative 19, this is an 11, and this is a 30. So if this is my number that was in the box, I would bring my 1 straight down. I'd take 1 times 1 and then add it, and this makes 2. 1 times 2 is 2. 2 plus negative 19 is negative 17. 1 times negative 17 is negative 17, plus 11 is a negative 6. And 1 times negative 6 plus 30 is a positive 24. So that one did not work because we have a remainder. So then I'm going to try another number. So I'm going to fill in the next number up we have is a positive 2. And so whenever I fill in positive 2, it would be bring the 1 straight down. And then 2 times 1 is 2. 2 plus 1 is 3. 2 times 3 is 6. 6 plus negative 19 is a negative 13. Oh wait, yeah, negative 13. 2 times negative 13 is a negative 26. Negative 26, which would make that a negative 15 when I add it to 11. And then 2 times negative 15 is a negative 30, which makes it a 0, and that makes this into one of our solutions. So we know we have 2 as a solution. And now I have my depressed polynomial sitting right here, because I don't have to have that 0 anymore. The 0 was my remainder, and that's my depressed polynomial. This is now an x to the third, or I mean, so this is my x to my third, my x to my second, my x to my first, and my number without. So I'm going to try, since I had a one positive number, I have to have a second positive number, so I'm going to keep going. I'm going to try 3. So I'm going to fill in my 3 now. So then I bring my 1 straight down. 1 times 3 is 3. 3 plus 1 is 4. 3 times 4 is 12. 12 and, oops, make sure I'm doing this right. 12 and negative 13 is a negative 1. I think I messed up. Let me start that part over again. Okay, let's try 3. And remember to use it with your depressed polynomial. So bring the 1 straight down. 1 times 3 is 3. 3 plus 3 is 6. 3 and 6 are 18. 18 minus 13 is 5. And then 3 times 5 is 15. And 15 and negative 15 is 0. And again, I've got my depressed polynomial to try for the next one. So 3 actually worked again. So now I've got my 2 positive roots. So x is going to be equal to definitely a 2 and definitely a 3. And so now I need to try some negatives and see if what I get for negatives. So I'm going to try a negative 1. And I'm using my depressed polynomial right here. So the 1 comes straight down. Negative 1 times 1 is negative 1. Negative 1 plus 6 is 5. And negative 1 and 1, or negative 1 times 5 is negative 5, so that makes a 0. And then that one works. Okay, so then I'm down to just this polynomial here. And so I have my actual answer right here. This is now an x to the first plus 5. And so x plus 5 is equal to 0. So then there's my last one. So we have our negative 1. And from this x plus 5, we have a negative 5. And so there are all 4 of my solutions. And it was to the 4th power. And so I'm done with that one.